A million miles from Earth, hidden behind a permanent shield of darkness, the James Webb Space Telescope drifts silently through space. It is not simply observing the universe. It is uncovering its memory. Every photon it captures has traveled for more than 13 billion years, carrying stories from a time when the cosmos was young and barely formed. For decades, scientists believed they understood what the early universe should look like. After the Big Bang, space was thought to be filled with a nearly uniform sea of hydrogen and helium. Tiny fluctuations in density acted like seeds planted across the cosmos. Over immense stretches of time, gravity slowly gathered matter together. Dark matter formed invisible scaffolding. Gas followed those hidden structures. Stars ignited. Galaxies gradually began to assemble. According to this picture, the first galaxies were expected to be small and faint. It should have taken hundreds of millions of years just to form the earliest galaxies, and billions more to build the massive systems we see today. The young universe, in theory, should have been dim, scattered, and unfinished. That is the version of reality the James Webb Space Telescope was built to confirm. Instead, it found something else. When Webb looked deeper into space than any telescope before it, it did not see fragile beginnings. It saw maturity. Within just 500 to 700 million years after the Big Bang, barely 3% of the universe's current age, Webb detected galaxies that were shockingly large. These were not tiny clusters of newborn stars. They were massive systems containing hundreds of millions, even billions of stars. Some appear comparable in mass to galaxies that exist today. This discovery immediately raised a problem. Galaxies are not supposed to appear fully formed. They are supposed to grow step by step. First, dark matter gathers. Then gas falls inward. The gas cools and collapses. Stars ignite. Those stars live and die, enriching space with heavier elements. New generations of stars form from this enriched material. Every stage requires time. Yet Webb is seeing galaxies that seem to have skipped the waiting. Astronomers began calling them universe breakers, not because they break physics, but because they stretch our models to their limits. It was like expecting to find the wooden frames of early construction and instead discovering finished skyscrapers. Scientists were cautious at first. Perhaps the galaxies only appeared massive because of distortions. Maybe gravitational lensing was magnifying them. Maybe dust clouds or unusual light signatures were misleading measurements. Some of these corrections did reduce the most extreme estimates. But not enough. Even after adjustments, there are still far more massive galaxies in the early universe than our models predict, roughly twice as many. And the pattern keeps repeating. Observation after observation continues to reveal bright, structured, unexpectedly mature galaxies at extreme distances. This is no longer a handful of anomalies. It is becoming a trend. The early universe was not quiet. It was already luminous and complex. This leads to an even deeper mystery. Because at the center of many galaxies lies something far more difficult to explain. Black holes are common in the modern universe. When massive stars die, their cores collapse into incredibly dense objects a few times the mass of our Sun. Over time, these black holes grow by feeding on surrounding gas. But this growth is slow. As material falls inward, it releases radiation that pushes outward, limiting how fast the black hole can grow. Even under ideal conditions, reaching billions of times the mass of the Sun should take around 800 million years or more. Yet Webb is seeing evidence of enormous black holes in a universe less than 500 million years old. Some signals suggest powerful energy sources only 100 to 200 million years after the Big Bang. At that point, the first stars would barely have had time to form, let alone die and create black hole seeds. So how did these giants appear so quickly? None of these explanations are confirmed. But they all point to the same conclusion: something in our understanding is incomplete. And the surprises continue. Webb is not only finding individual objects that formed early. It is discovering large-scale structure forming far sooner than expected. On the grandest scales, the universe resembles a cosmic web. Vast filaments of matter stretch across millions of light years, linking galaxies together while leaving enormous voids between them. Scientists believed it would take billions of years for gravity to sculpt such structure. If these observations continue to hold, our models of cosmology may require more than small adjustments. They may need fundamental revision. The early universe may not have been simple or gradual. It may have been dynamic, chaotic, and intensely productive from the very start. And Webb has only just begun its mission. Every new observation pushes deeper into the past. Every new dataset carries the possibility of revealing something even more unexpected. The question is no longer whether the early universe was different from what we imagined. The real question is how different it truly was.